Hello everyone. Today we are in Los Angeles to meet Dr. Yoshiaki KUWATA, the research engineer in Jet Propulsion Laboratory, JPL.
Right.
Nice to meet you, Dr. KUWATA.
Nice to meet you.
Now we are in Dr. KUWATA's house, the garden. Very beautiful garden. His study is robotics, space exploration, especially the planning and controlling of unmanned vehicle.
Right.
So, could you tell me about your research briefly?
My research
Yes, please.
on the planning and control
Yes.
in general. Right. So the Jet Propulsion Lab (JPL), the main mission of JPL is to do a robotic space exploration.
Okay.
And in the robotic space exploration, most of the system has a sensor that takes information from the environment, and the perception system that processes the sensing data, and then the planning and control part, which is what I'm doing. Based on this perceived environment, you make a decision on what the vehicle should be doing,
Okay.
and then the command gets sent to the vehicle hardware, which actually moves the vehicle. And my main research and main interest is in the planning and control part of the system. And usually the problem that I'm dealing with is, given a destination that you want the vehicle to go to, you try to compute the best path to get to the destination from where the vehicle is.
Okay.
So some part of the JPL works on the guidance or the trajectory of the actual spaceship from, say, Earth orbiting trajectory to the Mars, for instance. But what my group or the robotics group are doing is the surface vehicle mainly. So once you get to the Mars, how to get to the scientifically interesting places by computing the trajectory of the rovers.
Oh, I see.
That's what I usually work on.
So your vehicle will run on the surface of Mars.
Right. That's the main focus of the JPL's controls group of the robotics section.
Okay. That's very fantastic. Could you tell me some example of the past work or the work you are doing now?
Let me tell you two examples that I have worked on and I'm working on.
Okay.
One example that is a mission concept study for the Titan balloon. So Titan is a moon of the Saturn, and one big difference between the Titan and other planets or other moons is that Titan has a very thick cloud and atmosphere.
Okay.
And there is we know from the Cassini spacecraft's observation that Titan has a cloud and it rains, and it also has a lake made of either ethane or methane. And there's only a limited observation you can do from the orbiter because Titan has a very thick cloud. And JPL is planning to send a probe in maybe 2020 or 2030. And right now, the proposed concept is to use a balloon balloon in the Titan because it has a very thick atmosphere, and the gravity is not that big. And the problem that I worked on is, given the initial starting release location of the balloon, and if you know several scientifically interesting locations on Titan, what altitude profile you should be taking in order to get to those scientific targets using the wind field in the Titan. So that's one work that I worked on.
You can know the distribution of wind.
Right.
Before,
so there are some scientists actually working on this planetary wind field model, but of course they have only limited data points so far.
Okay.
So the planning and control system has to account for the uncertainty in the wind field and how they vary over time and what's the uncertainty in the model. And they have also several models of the wind field, and nobody knows which one is the right one until we actually get there.
Yes.
So there's some work to make the planner more robust to those uncertainties. And another work that I'm doing right now is about the future Mars sample return mission. So right now, all the spacecraft that JPL sends to Mars, we have several rovers, but they always go there and then take some measurements until the vehicle dies, and that's the end of the mission.
Okay.
What JPL is trying to do in maybe 2018 is we actually launch a first rover to Mars, and 2 years later we send another spacecraft that's called the Mars Ascent Vehicle. What it does is it picks a sample on the Mars and then shoot it back to the Earth, so that we can actually get the rock from the Mars. And the main focus of the study that I'm working on is, so you have two vehicles. First vehicle lands in 2019, and then drive around using several scientific instruments, and then take some samples, and then put it in the cache, and then leave it for the second rover that's gonna land in Mars about 2020 or 21. And the second rover gets to the cache location and then pick it up and then bring it to the Mars Ascent Vehicle, and then the Mars Ascent Vehicle will launch that cache back to Earth. And there are two rovers, and where to leave the cache and where those two rovers should land. You have to come up with the optimal strategy, and that's what I'm working on, using the entry, descent, landing model, and also the planning and control, how the rover should drive to get to the destination.
Thank you for your explanation. It's very amazing research. You're studying about the robotics space exploration, in which that means unmanned, the space exploration without man. But on the other hand, there are some researchers who studies the manned space exploration. So do you find any difference between the researchers doing the...
Yeah, so I see the values in both manned exploration and unmanned exploration. My main interest is in more in the unmanned part, mainly because it can do more advanced missions with and usually the development cost is much less than the manned version, because manned spacecraft you have to certify all kinds of safety criteria. For the unmanned missions, there are safety criteria, but it's not as strict as the manned missions. And what I usually bring as an example is the Apollo mission. All of the people remember the Apollo 11 that landed the astronaut for the first time on the moon. But actually there is a JPL spacecraft, several JPL spacecraft, those unmanned spacecraft landed on the moon to do the initial exploration. And those before the Apollo spacecraft. So those advanced, those dangerous locations that you still don't want to send a human, the robotic spacecraft can always go there first. And so far the astronauts have gone to only the moon of the Earth, but JPL has sent spacecraft to Mars and Saturn and Jupiter and all other solar systems. And so I think that unmanned missions can do all kinds of exciting missions that the manned mission cannot do with the time and money constraints.
You are still some interest in going to space, right?
Yeah, if I have money, of course I want to go.
You have a big interest in space, and you want to go to space. It's possible, but your study is the spaceship without human. So that kind of sense is very special. I think so.
Thank you.
So thank you, Dr. KUWATA.
Thank you very much.